Good afternoon. So this talk is going to be about the new tools in Visual Studio to accelerate developing XAML applications. XAML is sort of the cornerstone of part of what we released in the Universal Windows platform as a composition layer, markup language for building these applications. It's been around for a while. We started with XAML quite some time ago with WPF. How many folks here have built WPF applications? Do you still build WPF applications? A few of you. It remains remarkably popular today, WPF. And in some respects, it still has broader features set than what we've done in XAML and C#. We continue to enhance and improve what we've done there, but WPF is still wildly popular. So all of that is relevant here, actually, because a lot of what I'm going to talk about here, the features that we've added to support XAML in Visual Studio, also are relevant for WPF support as well. So if you build WPF applications, many of these things will be relevant to you. Today we're going to start off talking about what's new in Visual Studio 2015 for XAML, but across a broad range of topics. We'll talk about the language service, what we've done in the tools to support XAML editing directly. Then we'll talk a little bit about Blend for Visual Studio. Blend's a separate application that we ship as well. I don't know, it has varying degrees of people who are excited about Blend, but it's got a really relevant place in the ecosystem and the set of tools, so we'll talk about that a little bit. Then, my favorite features that we'll talk about here are about the new UI debugging tools. The new UI debugging tools make it much, much easier for you to diagnose and understand how your XAML is being composed and what parts of the XAML may be causing problems. We'll follow that up with a little bit of discussion about some of the new profiling tools. We've added some profiling tools that make it easier to determine where problems might lie. And lastly, we'll talk about form factor adaptive apps. Of course, this is the cornerstone of the Universal Windows platform, building applications that have a single binary, but provide a tailored experience based on what type of device they're running on. Nicola talked earlier, I think, after the keynote about some of the specific things like using Visual State Manager. That's the big thing that we talked about there. I'm going to talk a little bit about your ability to create. Hello? Cutting in and out a little there. I'll talk a little bit about custom forms that you can do as well in your single binary. So let's start out with the XAML language service. In Visual Studio 2015, we've moved XAML composition layer to be on top of the new .NET compiler platform, Roslyn. And this had a lot of implications. Moving on top of Roslyn created a foundation for a much richer environment for XAML editing. We wanted to make a XAML editing experience that was as feature-rich as the C# editing experience, because a lot of developers complained that working with XAML, a declarative markup language, was much more rudimentary than the feature set that they got editing C# directly. And we also wanted to improve the performance of the tools in editing XAML. One of the comments that we had gotten back quite a bit was that the XAML, there's a design layer, and that the design layer was not necessarily, it would impact performance, that you would have to wait for the design to compose at design time, and that this caused some challenges for developers. So most of this presentation is going to be demonstration. So I'll be going back and forth with the actual tools here, and probably easier if I duplicate. Let's see how that looks. Okay. Not as much resolution as I'm used to. But let's go in here into Visual Studio, and I've got an emulator instance running there. And I'm just going to launch this project here. Visual Studio 2015 radically accelerates a lot of the performance of many of these basic operations, like launching and so forth. What you'll see here in my compressed resolution here, but hopefully very visible. Standard IDE here with the toolbox on the left-hand side. And here's a XAML page in the middle, and then the Project Solution Explorer on the right-hand side. I'll just compress those a little bit. And I don't know if you guys have used this before. I find this extremely useful. The ability to have your scroll bar actually represent the full document on the right-hand side, and then you can actually see different parts of the document. That's available throughout, of course. And I believe that actually came in 2013. But what I wanted to show you here, you know, we had, right now I'm just looking at XAML, and of course I have the ability to split the pane so I can see, this is a WPF application, but of course these features are available for all applications that use XAML. I can see the design surface on the bottom here and the actual XAML declarative markup language on top. And so the first thing I wanted to show you, you know, we got a lot of feedback about folks about not really using the design surface in Visual Studio. So a lot of folks were like, you know, I don't want to take that performance hit. So what we've added now in Visual Studio 2015 under the XAML designer options here is this checkbox here. Now, we've always had this where you can actually set up the default view for your XAML pages, but now you can turn off the XAML designer altogether. And so I know it's interesting as a feature to talk about turning off something, but this was something that people really, really requested, is the ability. I don't want XAML designers in my Visual Studio experience, so that was something that we added, and then you reboot, and then you have that removed, and it does speed things up a little bit. Next thing I want to show you here in the XAML experience, we added support for regions in XAML. One thing about XAML files is that they do tend to get very, very long in terms of showing all sorts of features. So what you'll see here is that I've created a region, and I can actually now collapse that region if I want to simplify things and just within a set of text that doesn't necessarily correspond to a specific object. I can just create that region, and now I can collapse that. The final thing, let's go back to, I want to make sure I'm showing you everything. Let's go back to slides. Ah, yes, of course. So one of the most interesting things XAML Peak. So I don't know, have you guys seen Peak at all in Visual Studio? We now support Peak in XAML. So we've always had the ability, you know, you're dealing with code that represents objects that are created across many different files. And this presents challenges as a developer, not knowing necessarily where something is. And for a while in Visual Studio, we've had the ability, because objects are being defined in both XAML and code, you need to sometimes go back and forth across many different files when you're working on a particular execution. And you know, we've always had the ability here to say, you know, go to the object, but what we've added is this new Peak functionality, and Peak enables it so that you can actually say peak definition, and then you get inline here. Let's go get sure I'm on that. There we go. So you'll see that it actually opens up directly in place in the code. And I'm looking at two different files here, but you'll see since I clicked on that object there, main window, I'm actually coming in here, and now I can edit it right here in place. The other thing that's really interesting is that, you know, this operates across the entire application, of course. If I went in and I'm in here in the actual C# file, and if I rename this into, you know, my project main window, you'll see that that then operates across the XAML file as well. And so this is functionality here. I can actually expand the window to actually open up the whole thing, or I close it altogether. But Peak gives me that functionality. So Blend is the next thing I'm going to talk about here. Blend is a tool. How many of you have used Blend before? A number of you. Blend is focused on, and a lot of the functionality of Blend and Visual Studio have been merged over the recent years. In 2015, we actually have moved now to a single underlying set of functionality that we're exposing across both. We think Blend is a tool optimized for the development of the user experience and has a deep focus on best-in-class UI UI design capabilities, whereas Visual Studio is much more focused on creating the application, coding, with code editing capabilities. And so, historically, Blend has trailed Visual Studio in terms of the features that it provides. We got a lot of feedback about this. Blend historically had no XAML IntelliSense. The reload experience going back and forth between Visual Studio and Blend was rather poor. And then the shell and the project system didn't function the same way. We didn't have features in Blend that would have made a lot of sense, like support for source control with Git and TFS, the ability to expand and collapse project nodes. Very, very rudimentary. You'd expect that to be there. And then performance and scalability of very, very large solutions was rather poor in Blend as well. So what we've done in this release is rebuilt Blend from the ground up, using a lot of the different subsystems from Visual Studio itself. It retains the unique Blend capabilities, but it's also the foundation for a lot of work that we'll have going forward in order to provide a more rich experience in Blend. Some of the key things Blend does really well include the ability to do run design time, actually having sample data, and do design time data can be created automatically in Blend. You can do things like animation support with storyboards. Those are just, and then visual state management. That's actually now a very important piece of the platform. You can deliver completely using Blend as well. So it remains an important tool. What we've done in this release is a lot of work to actually support this. So let me show you some of this stuff. Going back and forth between Blend and Visual Studio used to be very hard. But now, if I go into my Solution Explorer here, you'll see I have the ability to right-click on any file and say Design in Blend. And doing that launches Blend on the wrong screen. Here we go. It launches Blend directly at that page. So we've got some overscan going on here. Let me try doing that. Okay, so now I have Blend, and you'll see here I have a Solution Explorer that mimics the Solution Explorer in Visual Studio, and I can actually go back and forth here and see the entire project in a manner similar to the way it appears in Visual Studio. I get the design surface, again, very similar to what you see in Visual Studio, but I can also go back to Visual Studio and click on any file. Say I want a different view, and here I want to look at the dashboard, and I say Design in Blend, and that will open up. So the support's been improved here so that we actually have the ability to contextually select and transition between the two environments on the fly based on which environment I'm using. Now, the next thing I want to show, I'm just going to take you quickly through some of Blend here. We've got support for, some of the things in Blend have been kept the way they were before. Like the asset panel here in the toolbox. This is sort of a more rich environment here with search integrated across things. Access to controls, yes, but also styles, behaviors. This is a Blend notion here that you can create programmatic behaviors that a designer could implement in your application without having to code. Shapes, effects, media, categories, and locations. Now, down here you have the object and timeline view. This object browser is similar to the one that exists in Visual Studio. Some of the things that we've added and enhanced here, however, include support for peek. So if I'm in here and I'm looking at a tab item, now one of the common things people do in Blend is you can right-click on that item and you can edit the template. And the template is the style that's getting defined in a different location. Since this is a declarative markup language, you might be defining that template somewhere else. If I go here and I say edit current, you'll see what happens is it takes me directly to the XAML file where that's taking place. But I can also go in here and let's go back up, see if I can get this to go correctly. Edit template, edit current. And I'm on the wrong piece here, sorry about that. Dashboard, main window. And edit template, edit current. It keeps taking me to the others. But you see, this takes me directly to app.xaml where that template is being defined. There's a way to, I think I'm on the wrong element is the problem. let's go to the core tab, tab control, and go edit template. Not that one. My first demo fail of the day. But this is actually, you get peak view here as well. And there's something about the way I'm doing this wrong that is not quite working. But the idea is that simply, the fact that something's defined in a different file doesn't mean you necessarily have to bring it up in a different file. And you get the ability to view it directly in context. The other thing, it may be that I don't have the design view showing. Let's try that. I'm on the wrong page. With the tab, go back over, core tab. Oh, I'm down 2. Let me close and open that file again. See if I can make this work correctly. This is my punishment for everything working in the keynote. All right. Edit template, edit current. There we go. So now you'll see the peak view, which just disappeared because I went out of it. But if I go back to the peak view here, let's try this again. Edit template, edit current. You'll see I'm seeing app.xaml in context of mainview.xaml, and I get this separate peak view in here. And it looks a little bit constrained, particularly because of the way that we're looking at this page on such a small resolution. But believe me, most folks doing this work have very, very high resolution screens, and this is extremely useful. We've gotten a lot of very, very positive feedback about what this adds to the experience, the ability to view in context the template directly here. If I wanted to go and change the background to, from right now it's data bound to a actual style setting, but if I wanted to change that to like red, you'll see directly underneath in the design view that changed immediately to red. Now, if I go back to Visual Studio at this point, what you see and what you've historically seen, I didn't save it, but let's save the file. And I go back to Visual Studio, you'll see I get this dialog box. And a lot of people were like, wow, that's really frustrating and annoying to get that dialog box every time I change from one and not the other. So what we've added here in Visual Studio 2015 is this checkbox here. You can set this checkbox here to always reload modified files, and then you just say yes to all, and then you no longer get that dialog box. So we've improved the round-tripping experience between the two based on that, and you can change that again later. The other thing I want to mention here, I didn't specifically show this before. We've got a different theme in Blend. And this was based on feedback from a lot of the designers who use Blend, that they wanted something that they could use that had more contrast for Blend projects. And so this is called the Blend theme. And you'll see here in options, you can change out of the Blend theme if you want to one of the Visual Studio themes. It's based on the dark theme, but it actually has some tweaking done to make it more contrast heavy so that the actual design experience is a little bit better. One of the other things we've done in Blend is improved accessibility. This was something that we got feedback from a lot of folks that you couldn't drive the whole thing with a keyboard. We've added full support for Control-Tab to give you access to every aspect of the interface. So using Control-Tab, I can now jump directly to any screen in the interface, and at that point then use the keyboard to do things like F2, rename, and so forth. Last thing I want to show in Blend is workspace support. Blend already had its own support for setting up all of the different pieces of the dialogue in a certain way, but we've enhanced that using the Visual Studio workspace system. Under Window here, you'll see Save Window Layout, Apply Window Layout, Manage Window Layout, Reset Window Layout. One of the things that people do a lot in Blend is they build storyboards for animation, so if I say new here and I create a new storyboard, you'll see a timeline, and some of the feedback we got was that, oh, this timeline on the left-hand side is really constrained. So what I might want to do is take this and have it go across the entire bottom of the screen or like that, and that gives you a better view for recording, or it would if I had design view up here. You can actually set different keyframes and then you basically control, move around how you want things to appear or transform, and then it will construct all the XAML necessary to, this is one of the biggest powers of Blend, is the ability to just use a storyboard to create XAML animation, and then it will construct all the necessary XAML to perform at runtime those animations based on whatever sort of trigger that you define. So it makes it radically simple to build powerful animations without having to actually do any XAML coding. But the point I wanted to say here, here this is a window layout. I can actually go save the window layout, and I have a number of different layouts that I can save and set up, and you can easily switch between the different layouts. You can also reset the window layout, which will very easily restore you back to where you were to start with. So that's Blend. But let's move on. Blend is just one piece of the puzzle. So here we go. Extend again. UI debugging. This is one of the most interesting pieces that I'm going to talk about today. All right. So XAML UI debugging, it can be very tricky to understand how XAML is actually executing in your environment. And this has to do with the fact that, like many declarative markup languages, XAML that actually gets executed at runtime by the XAML compiler will be the result of XAML that's located in your application in many different places. So you may have an app.xaml file that has a series of library resources. You may have a XAML template in your application. You may have XAML properties set directly on an object. But which one is controlling and where does it sit? And then there's the other problem that in many large organizations building XAML applications, you may have XAML files being contributed by multiple different sources. So as a developer, you may not even know why is something not look right when I'm running it. So this is the problem that we set out to solve. And so what we've added in Visual Studio 2015 is a visual tree inspection and manipulation with live tracking of the tree and property changes, and it's fully integrated into the debugging experience. So I'm going to take a little time to go through what that looks like here in Visual Studio. Let's go back to this view, a little bit easier to present. And we'll go back to our project in Visual Studio here. That's the wrong one. Let's open this one. So this is a basic project tracker application. It's rather complicated. It has a lot of different moving parts. And it's in WPF. Let's take a look here, and you can see just visually what it looks like in the design time view. It's got a little bit of a view here with, and what happens when I go and run this application now is after it compiles and runs here, you get in the actual IDE, you'll get and there are some performance issues with this application that we'll actually look at when we start talking about performance. But here's my application running, and you'll see here it's got a number of different grids and tables and views and tab controls. But I go over here and you'll see this is my new live visual tree. And this is showing you the entire tree of XAML currently represented on the screen. So right now there are 930 objects being instantiated. If I go over here, you'll see I click on a different tab. It changed to 619. This is reflecting in real time the number of XAML objects that are being created. And I can actually expand this tree and go down and look at all the different pieces. But that doesn't really help me if I'm trying to find out why, for example, these two entries maybe are not formatted correctly or they're too close together. Why is that? So what I can do here is I have a selection tool. I can click on that selection tool, and that gives me the ability now. I lose the ability to manipulate the application, but I can actually go through and you'll see the little red, can you guys see the red square? That's the red lines. So these red lines are indicating a control that I'm over. And if I click on one of those, now you'll see the tree navigated to the actual object that I'm on. And this is extremely powerful because what I can do then is I can come back over here and I say, show properties on that object, and I can see in real time, this is the live property explorer. In debug time, I'm looking at the text, and if I make a change here and change the text to my dashboard or whatever, you'll come back over here and you'll see this has changed in real time. So I can change properties on XAML objects at debug time and in real time see what the impact of those changes are. This is not where we're going with this, is we want to get to a full, real edit and continue experience with XAML. So we don't have that quite yet. What you're doing here is you're simulating these changes and seeing the impact that they have. You're not actually editing the file itself at this point. This is the start of a journey, like I said. We're getting to a richer debugging experience for XAML all up. I can now change the properties and see what they look like at debug time. We also have this feature here, this display layout adorners in the running application. And that's pretty cool because a lot of the problems that people want to debug are problems where they are trying to fix an alignment problem, a layout problem. And you'll see here, as I go through the application now in select and adorner mode, I can see it's actually showing me padding and margins on each of these actual objects that I'm hovering over. And so that gives you a more rich ability to actually see what's going on with regard to each of those pieces. Next thing I want to show here is we've got this preview selection tool. The thing that's nice about that, I don't actually use that one. That one gives you the ability to actually have everything update dynamically as you go. And I prefer to do it myself on a case-by-case basis. You can also click on here and say View Source, and then that will take you directly into the XAML file that you're looking at. And so you'll see here's text block. I've actually synced up to the text block in the file itself. The other thing that's really nice here is the ability to debug things like data binding, which can be very, very challenging to debug. If I come over to my application here, and I'll get out of select mode so I can manipulate it, you'll see here I have a combo box that's not populating correctly. And I want to figure out why isn't that populating correctly? That seems like a data binding problem. So if I turn back on selection mode, come back over here and I select that object, I can go over here and here's the combo box selected. Let's go view the source on that combo box. And right off the bat, because I know my code, I can see here that there's a typo in the binding. And so that's very, very instructive. The key challenge that we overcame here was the ability to find that piece of code quickly because navigating the XAML tree can be really challenging. I can also navigate collections. Obviously, in XAML and data binding, the fact that so many applications are list-based, collections become an important part of the puzzle here. And then finding the actual data context can be challenging too. So we have the ability to search here. And once I've searched in here, I can actually go into the data context on an initial specific item. And this is where I would also be able to see that this is misspelled. Okay, so that's the XAML binding experience. I didn't show setting local and resetting. So that's the other thing you can do. Other complex aspect of XAML, is the fact, like I mentioned, the fact that we have styles that may come from a whole range of different places. And you might want to be able to determine where that is. You might also want to be able to set things at debug time. And that's a problem with this project right now. Let's go back and reload. So I'm running my application again, debugging my application here, And say I want to actually go, let's select object again, and I'll select on dashboard here, and then I want to go look at my live property explorer, and I go here, and you can see that I have some properties on objects here being set locally. I also have styles that are inherited from different places in the tree. But the other thing that I have the ability to do is override them and set new features locally. So if I want to go in and set a local background, I can just do that here like this at design time. And that gives me the ability to, and you'll see here that that's reflected in my running application. So this is another way for you to manipulate styles at debug time and instantly see how those changes are reflected in the application. I'm still in selection mode. And of course, most developers are using a higher resolution screen than is possible for me with this right now. Back here. Okay. So coming up, we obviously, like I said, we're moving towards a model where we have a full edit and continue experience. We also are going to be doing work to serialize the edits that you make back into the source code, regardless of where that may be coming from and which file that may be coming from. We also know that data binding continues to be a challenge for lots of folks, so a lot of work is going into providing a visualization that will improve your ability to understand the data context of each of the objects that you're working on. Now let's move on and talk a little bit about profiling tools. We've had profiling tools in Visual Studio for some time now. We continue to try to improve those tools. We understand that one of the challenges people have been dealing with XAML just are the performance impacts. Obviously, XAML provides, especially with data binding, two-way data binding, the ability to abstract out some of the more complex aspects of composing a UI. By using data binding, you can provide that real-time connection to the underlying data source that empowers the UI without actually having to update the screen every single moment. But that has an impact on performance. Now, if you guys have been following along, at Windows 10, we added support for a new data binding with XBind, which does radically improve data bind performance at runtime. However, that said, there's still challenges to be with regard to understanding where you might have a bottleneck in your application. So in 2015's version of Visual Studio, we've done work to improve CPU, memory, and timeline views in the profiler. And this supports both WPF and UWP apps. But you do have to run Visual Studio on Windows 8 or higher in order to be able to take advantage of this. So we're going to take a quick overview and go through a number of these features here. Let's take a look. And I'm going to run a different project for this one, the stock application. And this stock application currently does have some performance problems in it that we're going to debug. So let's take a look here at this application. I'm going to run it, and you can take a look at what it looks like. Oh, sorry. Yep. Screen. All right. And so it's loading. Like I said, it has some performance challenges, so it is going to take a little bit of time here while it loads up. Oh, here. Okay. Yep, had to happen, didn't it? Let's see if we can muscle through it. No, hang on. All right, let's try this one more time. Worked this morning, I swear. All right, here we go. Nope, crash. Okay, great. You know why? Because I'm not on the web. That's why. Because I'm not plugged into the network. That is exactly why I'm hitting this problem. I forgot that I need network connectivity for this. And I don't have the dongle either. We could try and see if I can get on the internet here. I think people have been having trouble with this. Oh, pretty good, huh? You're suffering my pain with me. There we go, it says I'm connected. All right, let's give it a try. Come into that. Next time, modify the demo to not require connectivity. Anybody know any jokes? I was told not to say jokes when I'm on stage in the Ukraine. Is that true? I shouldn't. Well, I don't know. You know, it's always a funny thing when you're in a different culture. Sometimes things don't translate, and I don't know. Still going. It's just this fast network connection that's impacting my performance. Although that's not actually the performance problem here. But it hasn't crashed yet, so that's a good sign. There we go. Look at that. I solved the problem. Okay, but it's very slow, right? So why is it so slow? Why is it so slow? Well, what we'll do here is we're going to use the new profiling features to try to assess that. And I open up, I say start diagnostic tools without debugging. I'm not actually going to attach the debugger here because sometimes when you're assessing performance, you want to assess performance against how the application is going to really run. And just having the debugger attached massively impacts performance. So we want to start the debugging tools without the performance tools without debugging. If I was going to go one step further, I would actually compile a release version because the debug version is instrumented for debugging purposes, and that also impacts performance. But what I'm going to do here is I'm not going to do memory first. I'm going to start out, I'm going to do what's called application timeline and CPU usage. And so let's take a look at how that impacts. And so what I do is I say, let's collapse this so I can see better. What I do here, I say start. And so then I go start. And so this compiles and starts and runs the application, and you'll see that there's some real-time graphs that are going on here. Because again, we do have to wait for it to launch here and run. And there's some web calls going on, so of course the network connectivity is going to impact the speed even more. But it's kind of interesting to note that the diagnostic session's going on here, and I have that CPU utilization chart that's real time. That's a useful thing that you can use anytime you're doing any sort of debugging. In Visual Studio now on Windows applications. Just sit here and wait a little bit. Is anyone going to go play golf later? I thought that was nice that we have a golf course there. I don't play golf, but. Hello? Yep, there we go. Okay. And we're still going here. It's a minute two. Gotta wait till it actually comes up. Hasn't come up yet. Now, if I was a user waiting for this application, any of you may have experienced this situation, where the performance isn't necessarily all that good. People tend to not like applications that don't start fast, I heard. So anyway, let's keep going here because I want to actually get a good profiler that I can use. Again, I think this is really massively impacted negatively by the network situation. I forgot that I need networking for this. At some point here, and let's stop it because this is getting ridiculous. Once you stop here, the diagnostic session gets stopped and it starts to compose out. I think I can do this demonstration regardless of it having gotten to the final stage. So it's going through and it's analyzing all the ETW data, the trace data that has been captured over this period of time, composing some very beautiful charts, which we will see here once this comes up. This should not take over a minute. It should take less than a minute. Very impactful presentation, I know. Okay, come on. There we go. Processing data, now it's gotten past that point. All right. There we go. The point is that you suffer this so your users don't have to. Although I'm making you suffer it right now. There we go. So, and this didn't end up being a very, here actually you can see that there is a big problem here in terms of application startup. If I want to, some of the rich things that are going on here, here's my timeline. And my timeline view, you can actually filter the timeline to the time range of that particular event. We didn't actually get past this stage because it hung up on the networking, is what happened here. I can look at CPU usage and get a little bit more information too. Those are the two types of profiling that I performed here in terms of where was all the CPU going. If I drill down here, you get to this point where in the constructor, clearly it's in the constructor, there's a problem. It's this method around getting data. And so the problem that we have here with regard to getting data, let's see if I can get into, because we didn't get far enough into the application execution, I'm not able to jump directly, but I know my code, so I can go in here and take a look at the model. This is the problem here, this get data call. You can see that we're doing it synchronously. And so getting the data itself, which is where there's an internet call happening, which is totally what blew this demo. What I want to do is make that asynchronous. So that's really easy to do. I have it actually right here. All I have to do is comment out this version of the model constructor, and at that point, uncomment the version that I have that's using Task Factory to implement a background process to get the data, and that solves the problem. And so this is just a demonstration about how these new tools now make it possible to drill in and assess exactly where you might have some of these performance problems. Let's go back over here. I appreciate your patience, by the way. Okay, the next one, I want to show memory profiling. So let's take a look. This one I don't believe is going to have that same problem. So let's go back to the project tracker. Project tracker, like I said, has some problems because there's certainly some process here that's taking too long when we load the application and run the application. Sometimes that's really obvious, sometimes it's less obvious. But let's go in and take a look at the memory usage. And here what I'm going to do is I'm going to turn off those and take a look at, I got to turn off, you can only do one, you can't do memory usage. Sorry about that. Yep, same problem. Yeah, I hear you all muttering there. Okay, so let's go over here. And what I did is I opened up my project tracker application. I said start diagnostic tools without debugging. And I'm doing memory usage, and I go start. And at this point here, we're launching the application, build succeeded. This application is not the same. So what you want to do here is you do two things. One, you want to take a snapshot of the memory usage at various times. So before I perform a memory intensive application, I'm going to take a snapshot and wait for that to end. I come back here to my application, and I want to go over to time entry and change to report view. And here's where I have a lot of data being presented, and that's possibly taking too much time. I go in and take another snapshot, and this gives me the ability, now that I have those two snapshots, I can stop, and here it's parsing all the TW data. It's going to go through different memory aspects of the application that we performed. And it first has to stop the diagnostic session. That's perhaps the longest part of the process here. Processing the data, I've got the two snapshots, and I can see here that 3 megabyte increase in memory usage, which is perhaps with 200, it went from 195,000 objects to 266,000 objects. I click on that memory indicator there. That processes the snapshot, and I can start drilling in to the objects themselves that get instantiated. This is where you start to determine information around what objects were created where, why they were causing problems, and diagnose the problem. So that's how the memory diagnostics work. And close that application. Okay, Let's go back to this. Okay, now let's talk a little bit about adaptive layout. Clearly this is one of, and if you saw Nicholas speak earlier, I don't know how many of you saw the talk on Universal Windows apps. Not too many of you. Okay, well, so there are a number of different strategies in the Universal Windows platform for building a single application that targets multiple device types. Perhaps the ones that we think are the most important are involving using adaptive controls, controls that are intelligent and can actually recompose themselves based on the device that they're running on. So we have a couple of different controls like the combo box and a few where they actually compose themselves. Using basic reactive design principles can also take you a long way here too in terms of designing an actual form that will compose appropriately simply as a result of you leveraging things like star sizing and auto sizing on these controls as their properties. But the next stage is using something like Visual State Manager. Visual State Manager, you can define a trigger, and based on that trigger, the appropriate state is fired and it creates the appropriate view. So you can say if the effective pixel width is over 140 pixels, then show this screen, and then you can actually define the layout of the controls. We also have some new container controls that make this much easier. We've got something called Relative Panel. Relative Panel allows you to say that Control A is next to Control B, and you can define the relative position of the two controls. You can then change that relative position based on visual state. So you can say if the screen is, if the available window, and the other thing that's interesting about this is that you can actually do it not just for different device type. You don't define device type. We actually prefer, the recommendation here is don't fire visual states based on device type. It actually goes back to the principles of reactive design all up. When people first started talking about reactive design, the notion was you don't want to base it on the browser. You don't want to say if I'm in Firefox, do X, if I'm on, if I'm in Netscape, do Y. Properties that are determinative, that are not dependent on the actual browser itself, because those things are much more independent. So here you're not talking about if I'm on a phone, you're talking about how many effective pixels are available. The really neat thing about this is that it gets you the ability to not only have the appropriate display presented on device type, it also, because we now support on Windows 10, running these applications in a way that the user can resize, and let me just show you one here. The calendar and mail applications are great examples of this. If I go into the mail application here, you'll see that I've got, this is collapsing here, and you won't see this because of my resolution, but if I make the screen smaller, you'll see it went away. I don't have that anymore. This is an example of an application recomposing adaptively based on the available effective pixels. So that's a really powerful mechanism, but it's not always going to provide you what you need. Sometimes you're going to need to have a completely different view based on the form factor. And so we're recognizing that fact that there are just going to be times that you want to have a completely different view. What we've done in Visual Studio is we've given you the ability to create different XAML views for a single page and then control that based on the form factor. The way you do this here is you define a device family folder, and here we have here we've got device family desktop and device family mobile. And then inside those, we'll have a different XAML page for each one. Now, and then that will then leverage the same code behind, regardless of the actual one that gets fired. So you need to write both those pages. This isn't necessarily what we recommend. However, it is a very powerful addition to Visual Studio. I wanted to point out to you. So if I run those in the emulator now, this is a very trivial example. I don't have a beautiful example for you today, but if I run this in the emulator here, you'll see I get the version of the XAML page. This text is set in the mobile XAML view. And if I run it on the desktop, you'll see I get the, and I'm going to just run this on the local machine. You'll see I get the version of the file that's written for the desktop. And the reason compilation is longer now is because we compiled to native. I don't know if you guys know about .NET Native. So .NET Native with the Roslyn compiler now, it means that .NET applications will be much more performant for users everywhere. It means that developers' compile time is now longer as a result. Which is, you know, there's trade-offs to everything. So we went with the trade-off that we think users want faster applications, but it does mean that your application is compiling all the way down to native code as opposed to needing to be on top of the CLR. It also means that as a developer, when you're debugging performance issues, you also want to take that into account because you need to understand about how, and that's why you want to compile to release, for example, when you want to actually look at performance issues. So this was an example of just how you can create these separate views based on the family of the device. Let's go back to the slides. That's just one of several different adaptive layout approaches we just showed you. So, and that's about it for today. I wanted to take you on a whirlwind tour of some of the key new changes in Visual Studio to improve and enhance your ability to debug. I appreciate your patience with some of the network problems. But we've done a lot of work here, but it's just the start. This is the foundation as we brought the Visual Studio basic underlying services to blend, as we've recomposed XAML, the entire XAML layer on top of the same set of layers that we use for language editing. We've set the foundation for accelerating the rate of change here. We've already had one update to the Visual Studio tools for Windows 10, and we're in the process of producing another one. We're going to have another one very shortly here. So as we go, you're going to see more and more functionality added in this space. And really appreciate your attention today, and thank you for coming today at Dev Day.